Hey everybody, and welcome to a long-awaited update. It's now been almost a month since our test on September 1st, so apologies for the delay and thank you for your patience. I want to start by thanking everyone who made donations to support our testing. You all contributed over $1,100, and this money went directly toward covering the cost of installing and testing these prototype baffles. I posted a spreadsheet with all of my expenses, so there's complete transparency, and you can find an updated version of that in the video description. The support makes a big difference, so thank you very much. In this video, I want to cover three things: developments from the rest of the community, results from my friend Miles' Accusump test, and results from our test of the second prototype baffle. If you haven't seen the video where I introduced this baffle, or the other videos in this oil pressure testing series, I'll link those so you can catch up. In the past couple months, there's been an accelerated rate of development for oil pressure instrumentation on the FA24. As a result, we're also seeing more people from the community share data and conclusions from their own testing. It's really cool to see. I believe more than ever that having access to oil pressure data for these cars is important for people who are taking them to the track, and I'm happy that it's becoming more mainstream to record this data. As my friends and I say, data or it didn't happen. Even after we find a solution for this problem, oil pressure monitoring and logging is going to be important for this platform. It can help people understand pressure drops, but also help them make fact-driven decisions on long-debated questions like which oil viscosity should I run and do I need to run an oil cooler? So let's run through some of the instrumentation products that have come to market recently. And it's worth mentioning I'm not affiliated with any of these products and I can't vouch for them directly. Gerald Just Projects is selling the GJP IO box and pressure sensor add-on kits. These allow you to inject pressure data into the CAN bus, similar to what we're doing on our cars. Next, Ansix Auto is also offering a product which allows you to inject data into the CAN bus. Their product comes with a sensor, all the wiring you need, and a logic board in a nice metal enclosure. AIM now has a channel expansion product, which skips the CAN bus and allows you to connect its proprietary sensors into the expansion box, which then plugs into a data hub and then your data logger. If you want a more integrated solution and you're willing to buy into their proprietary solution, this looks nice. So those are the instrumentation products that are on the market now. The solution that we're using, developed by No Street Racing 86, is getting closer to being ready for broader adoption as well. The plan is to open source the hardware design and the firmware so people can order fully printed circuit boards, plug in an off-the-shelf ESP32 module, solder in some connectors, and have a fully functional CAN injector. You would still need to get a sensor and the rest of the wiring. We'll provide more info on this in the future. So it's great that people already have multiple ways of getting access to this data. And soon you'll be able to choose between a low cost, medium effort, open source solution, and more integrated products, depending on your desire. So that's the update on instrumentation. Next, I'd like to highlight some of the testing by folks in the community. BTR Justin posted a great video analyzing baseline data and a half-court overfill from a track day at Chuckwalla in Southern California. One of the things that Justin is able to demonstrate in his testing is that a half-court overfill does not resolve the pressure drops, but it does cause a reduction in their duration. He is now testing the Accusump baffle. He put out a video walking through the install for that product, and we'll share test results soon. I actually mentioned this in my last video, but Ansix has also demonstrated a set of modifications that's showing good results, most notably featuring a 2-quart Accusump with a manual valve. I clarified with them after they posted their video, and they reported that they turn on the valve once the oil is warm and then leave it on for the duration of the track day. The trade-off here is that at low RPM, they're accepting that they're going to have a significant overfill. I covered this in my last video, but as a refresher, at idle, FA engines have very low oil pressures, which will cause the Accusump to discharge all its oil. Anyway, they believe that whatever aeration this will cause is not a concern at low RPM. And if this is true, then it eliminates a lot of the concerns we've had with manual valves and makes Accusumps more appealing. More on this next. Okay, part 2, test results from Miles' Accusump test. In previous tests, we've compared oil pressures in multiple Gen 2 cars to a Gen 1 BRZ with an FA20 engine. The FA20 car is owned by my friend Miles, and while we have observed better oiling performance in his car than with our FA24s, he's also motivated to improve his oiling performance. He alternates between lower grip SX2 tires and higher grip RT660s. With increased grip comes increased cornering forces, which makes consistent oiling more challenging for all engines. The night before our last test day, Miles finished installing a 3-quart Accusump with an electronic solenoid valve, controlled by a physical switch in his cabin. As another friend said the night before, installing a significant mod to the oiling system on the evening before a track day, what could possibly go wrong? The first time I saw Miles on Friday, he pulled into the paddock along with the smell of burning oil and gray smoke just starting to leak out from his engine compartment. He opened his hood to find oil on the bottom of the hood, exhaust headers, transmission bell housing, windshield, just about everywhere in the engine bay. When he checked the oil level, it was no longer registering in the dipstick. Luckily, Miles had brought many additional quarts of oil. By refilling his engine, he learned that he had, let's say, externalized 1.5 quarts of oil. At that point, he realized that a relatively minor selling point of the Canton electronic solenoid valve was actually a problem in his engine. There are two features of this setup that we think are not really appropriate for the high cold start pressures we see in these Subaru FA engines. First, the valve. Unlike a manual valve, which is either open or closed, the particular solenoid valve he was using has a feature that allows it to recharge the oil reservoir even when it's in the off position. So it's either open when powered, or it's a one-way valve that allows oil to pass into the Accusump when unpowered. Second, there's a pressure relief valve built into the oil side of the Accusump. Canton's documentation states that this opens at 175 psi. On cold start with 0W40 weight oil and the electronic valve in the off position, enough oil pressure built in the Accusump that it opened the pressure relief valve and started ejecting oil into the engine bay. 175 psi seems quite high, and it's higher than I see on cold starts in my FA24. But there may be some variance in the valves, and we believe that post-refresh FA20 has slightly smaller oil passages to the heads, which could create slightly higher pressures at the block port where the Accusump is tapped in. Also, I'm running 5W30 weight oil, which has lower viscosity and would result in lower cold start pressures. ANSYS didn't see this problem because their manual valve blocked flow to the accumulator at cold start. But it's worth noting that this risk is there if you forget to switch off the manual valve. By sharing this setback, hopefully we prevent others from experiencing the same issue. When he actually got his car on the track, we saw very encouraging results with the Accusump. You can see the oil pressure trace is much flatter in the test, in blue, where the Accusump is active. So overall, with Miles' positive results and the results from ANSYS, we think accumulators are a viable solution, but the setbacks he encountered really show that you can't just throw on an Accusump and call it a day. You need to understand what's going on and engineer a solution that's appropriate for this platform. We're working on a set of changes informed by what Miles learned, and we'll share those when we have results. Okay, on to part 3, the baffle test. My test plan was to start the day with the oil level at or just above the max fill line on the dipstick, just like previous tests. Then I'd gradually increase the fill if we still saw pressure drops. After my first session, we unfortunately did not see a significant improvement. By the fourth session, I was running a 1 to 1.25 quart overfill, and the results from that session were actually quite good. I had never tested this significant of an overfill out of a concern for aeration, but I just decided to give it a go. Unfortunately, because we don't have baseline data with this level of overfill, we're not able to say whether the overfill alone could have stabilized pressures or the extent to which the baffle contributed. For what it's worth, my understanding is that GR Cup cars are running a 1 liter overfill as specified by Toyota Gazoo Racing North America. I believe that at a higher RPM, it's not likely that this overfill would cause any issues since oil is being distributed throughout the engine, lowering the amount of oil in the sump, meaning the crankshaft is not going to be dipping into the oil. Based on inspecting the dipstick in relation to the crankshaft, it seems likely that the crankshaft would dip into the oil with such an overfill on cold start. Especially for dual-purpose cars seeing daily use, there is some risk introduced here. In theory, you could add a liter at the start of your track day and extract it through the dipstick at the end if you wanted to avoid this risk. Back to testing. Also, unfortunately, our volunteer test driver, Joe, suffered a wheel bearing failure in his IS 500, which meant that he wasn't available to do a session in my car, so we don't have test data at his faster pace. Most unfortunate of all, though, is what happened later in the session. On a cool-down lap, my oil pressure suddenly went to near zero at turn 3. I didn't actually notice the pressure drop until after turn 8. At first, I thought the pressure sensor must have failed. I decided I would abort the lap and come into the pits to check on it. Then I noticed pressure went up to about 7 and back to 0. This was not good. Now I knew that the sensor was likely actually sending a signal and that I probably had 0 psi of pressure. I continued around to the hot pits, and as I lowered my speed, I started to hear a strange sounding exhaust note. thought or hoped it was from another car on track, but by the time I turned into the paddock, I knew the sound was from my car. I had Rod knock. The rest of the weekend was a blur of logistics to get my car 200 miles from Thunderhill to the South Bay. Thanks to everyone who helped me out with that. Miles, No Street Racing 86, Don from Speed SF, my friend Brian for lending me his truck, and my friends Alex and Tony for helping me tow it back home. At this point, we didn't know the cause of the failure, so it was important that we stay radio silent about what had happened. This news had the potential to be very concerning for a lot of owners, so I felt like we needed to try and root cause the failure before we shared anything. I actually went as far as to remove the numbers from my car in order to make sure that we didn't have the classic car on tow truck photos online before I could explain what happened. The following weekend, I towed my car to another friend's house, thank you Kevin, and we were able to remove the oil pan and see if there were any obvious signs of a cause. What we found was very clear. A piece of the baffle designed to block crankshaft windage had broken off and was sitting at the bottom of the oil pan. It was maybe 2 by 2 inches in size. I won't be showing photos of this, but it was not a rubber trapdoor. It was part of the metal baffle itself. It was clear that this part had been sucked up by the pickup, causing complete oil starvation. We reported our findings to Varus, and they immediately agreed to cover the cost of replacing my engine, which I'm extremely thankful for. I need to emphasize a few points here. One, this failure is not representative of general FA24 reliability. While this is the first FA24 failure that I'm aware of with data logging, including oil pressures, it's not going to look like a typical rod bearing failure. With a typical failure here, you'd expect reduced pressures, but not to get to 0 psi. The second thing I need to stress is that this does not reflect on Varus's product quality in any way. This was a rapid prototype developed to test a hypothesis as quickly as possible, not a market-ready product. I would not expect this type of failure to occur in a product that was actually brought to the market. Last, modifying your car has inherent risks, and I was aware of those risks when I started down this path. There's no such thing as testing a one-of-one prototype without taking on personal risk. This is also why I stressed some of the risk factors in accumulators and dry sumps in my previous video. It's important that we understand the risks that we take when we modify our cars. Many modifications have performance improvements, but also come with downsides like additional maintenance burden or added failure points. We've now ordered and received a new engine, and I'm working with Ezekiel from CM Auto House here in the Bay Area in order to get it installed. My plan is to break in the new engine according to the standard procedures, and after that switch to 0W40 motor oil and start testing accumulators. For now, I'm planning to leave this engine unbaffled so I can isolate the improvement accumulators alone provide. We may still find that the baffle is necessary, and No Street Racing 86 will be trying an accumulator with his Sims baffle. I'm also going to send in my post-failure oil for used oil analysis. I think it'll be interesting to see what a worst-case used oil analysis looks like for this engine. At the very least, it'll tell us which metals we should look for in analysis results, since I haven't been able to find bearing composition details online for the FA24. Varus is looking into other solutions now as well, particularly seeing if they can develop a higher capacity oil pan. Since we're seeing encouraging results with overfills, the idea is we should be able to get the same benefit as an overfill without the downsides of risking crankshaft aeration. This idea has been implemented in an 86 racing series in New Zealand with FA20 engines. It may be necessary to pair a high-capacity oil pan with a custom header in order to free up some space. The area around the existing pan is very tight. We'll see what they come up with, but there's also no promise that it ever comes to market.
Finally, I'm going to start a new fundraiser on PayPal. This fundraiser will go entirely toward the cost of engine replacement. Varus agreed to cover the cost even though we didn't have any kind of legal or commercial relationship, and out of appreciation, I'd like to help reduce the cost to them. We as a community are fortunate to have companies like Varus putting their effort and resources into developing products to improve the performance and reliability of our platform. Sometimes products work out in the first try, but oftentimes they don't. We're definitely not expecting to recoup all the costs, but if you feel so inclined, any donations would be much appreciated. With that, thanks for coming along for this journey, and I'll see you out there soon.